Okay, the next set of problems asks you to switch back and forth between polar and rectangular form. So let's try to remember that polar is in r theta form and rectangular is x and y. And we know some things. We know that r is the square root of x squared plus y squared, right? We know that x equals r cosine theta and y equals r sine theta, and we know that theta is the inverse tan of y over x. So we know all these things, and it helps us. So memorizing this information right here will really come in handy. So the first thing, number 19, says go from polar to rectangular. And it looks like this is a rectangular, but it actually says it's polar, so that means that r equals 2 and theta equals 0. So I will just use my x equals r cosine theta and y equals r sine theta to do this in rectangular. So x would be 2 times cosine 0, or 2 times 1, so is equal to 2, and y equals 2 times sine of 0, which is 0. So my rectangular point is also 2, 0. Now that just is coincidence. Okay. Number 20. We have to go from rectangular, so we have 3 halves and 3 square root of 3 over 2, to polar. Okay. So in this case, we need to get an r, and we know the formula for r. R is the square root of a squared plus b squared, or x squared plus y squared. So that's r equals the square root of, now take your time to do this, 3 halves squared plus 3 square root of 3 over 2 squared. So r is the square root of 9 fourths plus 9 fourths, well, it would be 3 times the square root of 3 squared, which is 9 times 3, so that's 27 over 4. So make sure you understand that and you take time to get it right. And so that's the square root of 36 over 4, which is the square root of 9, which is 3. So we have r is 3, so one of our points is 3. And now we have to get theta. And theta is the inverse tan of a over b, b over a, I'm sorry. So 3 square root of 3 over 2 over 3 halves. So just take this complex fraction. This would be 2 times 3 square root of 3 over 2 times 3. So you just get the square root of 3. So 3 the square root of 3. Oops, that's not right. I forgot to take the inverse tangent of that. I'm sorry. Theta equals the inverse tangent of square root of 3, which is equal to, where is this tangent square root of 3? All right, this is important because you can't, it's different places the square root of 3, right? You don't know what quadrant. You have to go look up and see what quadrant is the original point in, and that was quadrant 1. So we're safe saying this is pi over 3. So the answer is pi over 3, but you need to make sure you look at the quadrants for these. Okay, it might not always be quadrant 1, all right? Some of you really missed that on your quiz. I think I can do one more on this video. So we're on number 21. Sorry, I keep going back. Number 21. Convert the equation from polar to rectangular. Okay, so we're given theta equals pi over 3. Now remember all the things that we learned. The only thing we know about theta is our inverse tan run, right? So we are going to say that theta is equal to the inverse tan of y over x. So let's just say pi over 3 equals the inverse tan of y over x. And that just means that the tangent of pi over 3 is equal to y over x. And so that means x, if we're solving for y, times the tangent of pi over 3 equals y. And what's the tangent of pi over 3? We just saw it was square root of 3, so x times the square root of 3 equals y. So that looks like it's C. This answer would be C. Oh, 19 was C also. 19 was A, and 20 was C. Okay?